matrix algebra, but MATLAB, like I said, it's its own short notation. So you have to be careful when you use it, make sure that's what your intent is. So A plus 2, see, it added 2 to every element of the matrix. Unlike the other one where it had the A plus U, which didn't make any sense whatsoever. Okay? Okay, oh, format. No, not to that yet. Oh, element by element. This is important. Okay? You can do this a lot. You'll see in some of the graphics that we're going to do. S is 1, 2, 3. Okay, so S is the row vector 1, 2, 3. And T, I'm not going to print them out, is 5, 4, 2. Okay? 5, 4, 2. Okay. So S and T are in memory, even though you don't see them. Okay? There's S and there's T. Okay? S is 1, 2, 3, and T is 5, 4, 2. Now, if I did S star T, in linear algebra, star is for multiplication, and in MATLAB is a vector-based or matrix-based program. So if you do S times T, it wants to multiply the matrix S by the matrix T. Now, in linear algebra, can we do that? No, because S is a 1 by 3 array, and T is a 1 by 3. The unit dimensions have to agree. So if I do in MATLAB S star T, it'll give me that diagnostic like I got before. Inner matrix dimensions must agree. If you have S on the right, which is 1 by 3, it only can multiply a 3 by something. Okay. But here's something you want to do many times, okay? And we're going to see this over and over again. Many times you'll have this array S and this array T, let's say, and you want to do an element by element multiply. In other words, I want to do 1 times 5, 2 times 4, 3 times 2. Okay? So MATLAB has a short notation that allows you to do an element by element multiplication. And what it does, it takes that star and it puts a dot in front of it. Let's do S dot star T. Okay, before I did S star T and I got an error, if I do S dot star T, MATLAB says, oh, it sees that dot. It says whatever the operation following the dot is, you want to do it element by element. So we should get 5, 8, 6. Okay? You'll see this a lot in the graphics when we do, especially when we want to plot functions. We're going to use this a lot. Okay? Element by element multiplication. Okay.
Professor?
Yes.
So if you had a 1 by 3 and a 3 by 1, you would result in a 3 by 3.
Yeah.
Right, if you multiply them?
Yeah. Element by element. Okay. Oh, format I want to talk about. Format chart, format long. Okay. There are a lot of built-in functions in MATLAB. For example, square root, you can imagine square root of 9, 3. Okay, sines and cosines. I can take sine. Now, you have to be very careful. SIN in MATLAB is in radians. So suppose I want the sine of 30 degrees. I'd have to take basically pi over 6, right? You get a half. Now, MATLAB knows that a lot of engineers like to do things in degrees. There's another command called SIND, which means sine in degrees. And that's 30. It's a half. Okay? Same for tangent and cosine and all that. Okay? A lot of, just any function you probably know what MATLAB has. Okay? Error functions, probability, special functions in mathematical physics like Bessel functions and stuff like that. A whole big library. Okay? Now, there's also, we'll explain this over here, the search thing is really good to get things like that. Like suppose, for example, you want to do a tangent of something and you're not just sure of is it TAN, is it TANG, okay? You can put in here let's try trig. It's already filling it in. Trigonometry, see? Okay. And what happened? It should give me some help on that. Oh, there it goes. Okay. It's the help page. See, trigonometry, sine, cosine. See, it's all in a very nice, what's called a taxonomy tree. It goes from the general and it goes down and down. So if we hit trigonometry, okay, look at all this. Okay, sine, okay, see, everything that you can possibly, hyperbolic functions, etc., etc. Okay, so this is a very good thing to use over here. You just put in, and what's nice about it is that some languages you have to know the name of the function. This is almost like a Google type thing where you put in a general description and it gives you to the page that's closest to that. Okay, so that's a good thing to know. Okay, Now, what about things like pi? Okay? Sorry. Let me set z equal to pi. Okay? All right, I have to do that because it's pi. Okay? Now, you see only there 5 significant digits. Okay? When you do a computation with the MATLAB, okay, internally it uses its full precision, but most people don't want to see too many digits, so it just truncates it like that. Okay? But you have to realize when it's doing the actual computation with this, anything that you have, okay, it always uses its full precision. Suppose you want to see more digits on something, okay? There's a command called format, okay? What we have here by default, when you open up MATLAB, it goes to what's called format short. There's also a thing called format long, which will give us more digits, okay? Now, once I execute format long in my MATLAB session, it will continue format long until I shut it off, going back to format short. So, for example, if I do pi now, see, get all those digits, square root of 2, which before was just, 1.414, something like that. Now it comes out to be full precision. Okay? Let's go back. And you also can do things in exponential format. Just look up the format command in the help, and you'll find out how to do that.
If you wanted more, would you write format longer?
No, I think that's it. I think format long, I think, is the most. But you can actually say how many digits. You can control how many digits that you want. So format. Let's go back to format short. Okay. Okay. So we did that. Oh, very, very useful thing called linspace. Okay. Suppose I want a vector to go from minus pi to plus pi. Okay. And I want to do it for graphics. Okay. And I'll say steps of 0.01. Okay. Here's the problem. It will get minus pi, it'll add 0.01, add 0.01, and then as soon as it goes above pi, it'll stop, but it's not going to hit pi exactly, right? Because you can't get from minus pi to plus pi steps of 0.01. So let me just, for example, I'll show you. For example, let x equal minus pi, what do I say, increments of 0.01. Let's do increments of a tenth, okay? All the way to pi. Okay? So it's kind of big. Let's go back. You notice that the first element is definitely, minus pi. But look at the last element. Okay? 3.0584. Right? Because when you start okay? So suppose what I want to do. Now you can figure this out, of course. It's a pain in the neck. You can say, okay, I want to go minus pi to plus pi. What increment do I have to take if I want to have 10 points to get exactly there, okay? But there's a thing called linspace, which MATLAB has, and it basically, you give it the starting point of the interval, the terminal point, and how many points that you want, and it'll give you the vector exactly. It'll hit the terminal value and the final value. Sorry, the terminal value and the starting value. As an illustration, let's do x equals, it's called linspace. Okay? Now, if I do just minus pi to pi, okay? How many points does it take? There's a default. Linspace, if you just give it the starting and the terminal value, it'll divide that into 100 points. It'll give the exact value, okay? Okay? I'm not going to, I put a semicolon on there, and you'll see that x is 100. If I do whose, you'll see that x is 100, okay? What's x of 1? Right? And what's x of 100 is that, as a matter of fact, you can do format long and you'll see that it's exactly pi, okay? Now, suppose I want to do the same thing, but I only want 10 points like before. Remember I did minus pi to plus pi, and I gave it an increment of, I think, of a tenth or so. I specify what the increment is. You could do the following. You could say, let x equal linspace. That's another argument to linspace, okay? Let's go minus pi to pi, but let's just do 10 points over there, okay? And of course, you can do this yourself. It'll figure out exactly what the step has to be in order to hit pi with just 10 points in there. And I'll just kind of show you to there. See? See how the last value, element 10, is exactly pi? Okay? Yeah.
So for linspace, the step is the last number?
Yes.
Except the middle?
Yeah. Linspace has, in general, 3 arguments. The first is where you want to start, the vector, where you want to end, third one is a number of points that you want.
Okay.
It figures out the step for you.
Okay.
Right? Like for graphics, many times, 100 points makes it very nice, and that's why lid space defaults to 100. But suppose that you do something that's kind of, you look at the graph and it's kind of, changing rapidly. You want more points, so you do lid space. The first value, the second value, 200. Let's say 200 points. Okay. So last argument, the lid space is the number of points you want to divide the interval into. Okay. Let's do some plotting now. Okay. I'm going to plot cosine of x on minus pi to plus pi, okay? And I'll just be lazy. I'll say x is equal to lin space. Helps if you spell it right. Minus pi to pi, okay? We know what that does. Oh, yeah, sure, okay. Did you mean, boy, it even says, gives you that. Okay, good. And then I'm going to plug into y the cosine of x. Okay, notice I did it in radians, okay? So I use cosine of x, okay? So now you'll see if you do a whos, let me clear the workspace over here and just start this again because there's too many variables that we've collected. Do clear. Okay, so x equals lin space, okay? Y equals, I'm using some, there, cosine, okay. If I do a whos now, you'll notice basically, of course, x and y are the same dimension. Makes sense. Okay. There's another thing which I should mention when I did this is that it's called what's called vectorization. Okay. X is a vector, 1 by 100. That's what lin space created for us. Okay. When I say cosine of x, okay, I don't notice that unlike other languages, I also do cosine of x of 1, cosine of x of 2. Okay. If MATLAB sees cosine and it's a vector, it understands you want to take the cosine of every element. Okay, that's called a vectorized function. That's exactly what we want to do when we do a graph, right? Okay, so even though x was a vector, I could do cosine of x, and MATLAB knew to take the cosine of every element. And obviously, therefore, y and x have the exact same dimension. Now we want to see a plot of that. MATLAB has a command called plot, which I suggest you look at in the help. A lot of things you can do. I can't illustrate everything here today. Do plot x, y, and what will happen is that MATLAB will come out. This is what's called the command window, what we're seeing right now, okay? What will happen is that MATLAB will not clutter your command window. Another figure window will pop up. Okay, it's called the figure window. It has your plot in it. So we do that. Okay. Should take that one. There we are, figure 1. And notice you got the cosine, okay? Very raw. All it does is plot the thing. It shows the color for you. You can override that, as we'll see in a second. Okay, it scaled the axes, how it had to. And you have no information there, like a title and the axes. You put that stuff in, later, other commands to do that. But it did plot the cosine minus pi pi. We know what that graph looks like. Okay. Let me show you now how to label that thing. I'm going to put on the x-axis just x, and the y-axis I'll put y equals cosine x. Okay? And I'll put a label, y equals cosine x. Oh, I see. I'm going to do 2 different things for you to show you. Okay. Now, the important thing is that don't hit this because this thing will go away. Okay? Okay? And then what happens is, as long as this figure window is still there, any plotting commands that I now issue, MATLAB will do to this plotting window. Okay? So we'll just put that on the side over here. Okay? And let's put some of this stuff into there and see what happens. Let me put in some label on the x-axis. If you look at the plot command, you'd see all these other things, that someone who's new would look at plot and they say, well, how do I put axes on the plot, stuff like that. And all that information will be there. And to get an x-axis, it's called x-label. Okay? And now it's a character string, so that's why it goes in quotes. You can put anything that you want over here. You can say, cost of radio or something like that. I'm going to just put x over here. Okay? That's for the x label. Okay? And for the y label, let's go along the y-axis. I'll say y label of what I have, y equals cos x. Like that. Okay. Something jumped. So I don't know what's going on. Okay. Boom. Okay, let's look at the graph now, see what happens, right? You'll notice that you have x, right? And then tilt your head, why equals cos x that way? Okay, and again, that's the default because usually it's gonna be long and you want it that way. But suppose for some reason, I just wanna, this, I did, one time, I wanted to have this thing y equals cos x horizontal, I'm gonna rotate it. I'm gonna do that for you now. Yeah.
So if you input another plot command, would it plot it here on this figure? Or would it make it
Yes,
bigger?
yeah,
Okay.
you have to be careful. To do that, I'm gonna show you how to do that. You enter a command called figure, and it opens up a new figure window. Yeah. Okay, so what I'm gonna do now is get that y equals cos x, but rotate it, okay? And let's just go over here. So the way I do that is I do the y label again. Okay, now I'm gonna put rotation 0. I didn't know that. Interesting. Yeah, I do y label y equals cos x rotation 0. Okay, and what will happen? See, before I just did y label y equals cos x. Now I added another one, an argument called rotation, which is it knows about, and how much you want to rotate it by 0. When you think that if that's that, you rotate 90, you would say, but I didn't write the program. Okay.
It rotates it to 0 degrees?
Yeah, I guess so. Let's see. See? There. Okay?
So if you do rotate 90, it'll make it vertical again?
Probably, yeah. Why did I put it? Oh, well, the 0 is in there from the axis. Okay, so y equals cos x like that. Okay. Now, what about a title? Okay, a lot of times you have a title on the top. You want to do that. Okay? So let's see how we're going to do a title now. Okay? Okay, again, if you look at the plot command, most of these names also are pretty logical, So title, T-I-T-L-E. You can put anything that you want. Again, it's a character string. So what do I have for the title? Graph of cosine function. Okay? Now, of course, there's a lot of default things you have to do. It's going to say, what color is that going to be? How big is it? What's the font size? What font is it going to use? There's a default, okay? Let's see what that looks like. And we'll change it because maybe we want something a little prettier, okay? So, graph of cosine function, okay? And what I'm going to do next is make the font a little bigger. Notice how it's pretty small.